So what was the last topic we were discussing? Lens makers for nerds. Last 15 minutes we'll have the So write down the next heading as prism. So in prism, you have something like this. So when we discussed about lens, what did we say? Lens has two refracting surfaces, where at least one of the refracting surface should be spherical in nature. Whereas when you talk about a prism, right? So it also has two refracting surfaces where both the refracting surfaces are planar in nature. So if there is a shape where both the refracting surfaces are spherical in nature. So if you have both the refracting surfaces, sorry, not spherical, planar in nature. So if both the reflecting surfaces are planar in nature, we can call that kind of an optical device as a prism. Okay. So if I take this as the first refracting surface, this as the second refracting surface, it is actually looking in the shape of a triangle. So this is also called as a triangular prism. It's called as triangular prism. Okay. Now, for this triangular prism, we are going to calculate how the other values are. So for example, if I take an incident ray to hit the surface at the first refracting surface, okay, then I'll draw a normal to the surface. Then this angle is called as the angle of incidence. Had this refracting surface not been there, the ray would have traveled in a straight line like this. But the ray is traveling from rarer to denser medium. So when it is traveling from rarer to denser, it starts bending towards the normal. When I say towards the normal, it bends between the actual path and the normal. So it is incident at the second point. So at the second point of incidence, if you draw another normal, at the second point of incidence, if you draw another normal, then the ray travels from denser to rarer. So it starts bending away from the normal. So what is going to happen here is this angle will become R. Okay. So that this is the incident ray. The inner ray is called as the refracted ray. And this ray is called as the emergent ray. Okay. The angle between the extended incident ray and the emergent ray. The angle between the extended incident ray and the emergent ray is called as angle of deflection. And angle of deflection is represented by the symbol delta.
Sir, can you repeat angle of deflection?
Which one?
Angle of deflection.
So you extend the incident ray and you extend the emergent ray in the backward direction. They both meet at a point, making an angle delta.
Okay.
Here. So I wrote it as R. Sorry. It should be E. Okay. And this angle is called as R1, and here it is called as R2. Now our job is to find what is the relation between all these parameters. So if I take this to be AB, CD, okay. So if I take the quadrilateral like this, if this is A, then observe AB, this line is making an angle 90 degrees. In the sense, this whole thing is 90. So this will also be 90. Right? Because observe, BC is a normal, DC is a normal. So BC and DC put together is making this quadrilateral. So this angle will be 90. Similar is the case on the other side as well. This angle will also be 90. So this is also 90 degrees. So if I take this angle to be C, then what is the C equal to? So actually it will be like this. A plus C plus 90 plus 90 is going to give us 180 degrees. Because it forms a, which one? Oh, sorry, 360. So it'll give you 360 degrees, right? So 180 is gone from here. If it goes to the other side, A plus C will be equal to 180, which implies C will be equal to 180 minus. Okay, let this be equation number 1. Okay. Similarly, if I take the triangle BCD, if I take the triangle BCD, right, this angle is R1, here it is R2, then how much will this angle be? 180 minus 180 minus of R1 plus R2. Is it right? C and D should be BDC. But this angle is what I'm trying to talk about. I hope you understand. 180 minus R1 plus R2. But the same angle is how much? But the same angle C, it is also 180 minus A. So when you equate both, what are you going to get? Solve it, I think. So you get A is equal to R1 plus R2. So from 1 and 2, from 1 and 2, what is that we can observe? 180 minus A is equal to 180 minus of R1 plus R2. So 180 is gone, which implies A will be equal to R1 plus R2. So the important point that we need to make a note is the angle of prism. So A is called as the angle of prism. So angle of prism is equal to the sum of the angles of refraction.
So can you show the previous page?
So first, everyone copy this. Done. So copy it. Yep. Have you done copy?
Yes, sir.
So listen. Next is condition for. Okay, but before that, we didn't find out what is the angle of deviation, right? So, if you look at, let's say this triangle is E. If you look at the triangle DED, okay, if you look at the triangle DED, then this angle is delta. Is it right? So here when the normal was existing, this was R1, and here when the normal was existing, this was R2. Is it right? Tell me one thing. Observe the diagram clearly. If this angle is I, how much will this angle be? I, because they are vertically opposite. So how much will the remaining angle be? I takes this is I and this is I. Out of I, R1 is what? I minus R1. So this angle will be I minus R1. Similarly, what will be the angle here? E minus R. Okay. So this is I minus R1. Now, what is the relation between delta I minus R1 and E minus R1? Delta equal to I minus R1 plus E minus R2. Right? So then delta will be equal to I plus E minus of R1 plus R2. So it will be I plus E minus A. Because what is R1 plus R2? So delta will be equal to I plus E minus A. Clear? Is it clear? Okay. Now, there are three mathematical relations that we saw. What are they? A is equal to R1 plus R2, and the C is equal to 180 minus A. And the third relation is delta. Angle of deviation is equal to sum of the angle of incidence plus angle of emergence minus the angle of prism. Right? So these are the three formulae based on which we will be solving problems. But before that, there is another concept also that we need to make a note of. That is called as condition for minimum deviation. So write it down. Write down the heading as condition for minimum deviation. Okay. So what does this state? If you see, let's say you have a prism like this, a triangular prism. Let's say this angle is A. Now this incident ray is coming and hitting the surface in such a way that the refracted ray is getting bent slightly in this way. Right? So what I can conclude is the extent to which the refracted ray is getting bent depends on the angle of incidence. So when you make it incident at different angles, right? When the first ray is incident at different angles with respect to the normal, the refracted ray will take a path dependent on it. But if there is a possibility where the refracted ray, instead of traveling in some random direction, if it starts traveling exactly parallel to the base. So when it starts traveling exactly parallel to the base, now what is this refracted ray going to do? It is going to act as an incident ray for the second refracting surface. So from there, what is happening? There will be another ray that is coming out. Is that point clear? Now, who is deciding the angle at which this emergent ray is supposed to get bent? Decided by the refracted ray, right? But the angle at which the refracted ray is supposed to be bent is decided by the incident ray. So having all these things in mind, what we can say is when you extend the emergent ray the backward direction, you are going to get delta. Right? So here I'm saying condition for minimum deviation, right? Means if there is a scenario where the refracted ray is becoming exactly parallel to the base, you can say that the angle of deviation in that scenario will be the least. We have the least deviation possible. So if the incident ray is hitting the first refracting surface in such a way that the refracted ray inside the prism becomes parallel to the base. So when it becomes parallel to the base, then the emergent ray will come out in such a way that the angle of deviation will be the least. Because if you look at the angle of deviation formula, what are all the parameters on which it depends on? I plus E minus A. So E itself is decided by I only, indirectly. Is that right? So it depends on angle of incidence and the angle of prism. Angle of prism is constant because you're keeping the same prism. But what are you keeping on changing? You're changing the angle of incidence. As you keep repeating this experiment multiple times, there will be one particular instance at which this kind of a scenario will occur. So in this scenario, what will happen is, observe, if this is I, as soon as the ray becomes parallel to the base, if this angle is R, this angle will also be R. Means I'm trying to say R1 and R2 will be R itself. And the angle of emergence will be in such a way that it will mathematically be equal to the angle of incidence itself. Means the whole scenario is symmetric. Whether you look from the perspective of incident ray and come out through the emergent ray, or you go through the emergent ray and come out through the incident ray, they both appear to be symmetric. Okay, in this scenario, you can say delta is least, and when delta is least, you put a suffix called as N, which you write it as delta M, means angle of minimum deviation. So delta M is called what? It's called as the angle of minimum deviation. Is this point clear? Right? So in the case of angle of minimum deviation, what will happen is, we know that A is equal to what? R1 plus R2. But what is the relation between R1 and R2 in this scenario? They both are equal. So from this, I can conclude A will be equal to 2R, and let me call this as equation number 1. Similarly, what is the relation between delta I, E and A? Delta will be equal to I plus E minus A. I is I only. What is E? That is also I minus A, which implies delta minimum. 1 minute, small correction, wait. So delta is I plus E minus A, but delta M is I plus, in the place of E, I'm substituting by I minus A. So delta M will be equal to 2I minus A, which implies 2I is equal to A plus delta M, or I is equal to A plus delta M divided by 2. Let me call this as equation number 2. Okay. Now A is equal to 2R. I will be equal to A plus delta M divided by 2. Okay. So from this, what we can conclude is, remember, A is equal to 2R. I is equal to A plus delta M divided by 2. So from this, what can I say? R will be equal to A by 2. Is it right? So R will be equal to A divided by 2. And you mainly do this experiment to find out the refractive index of the glass prism, or refractive index of the prism itself. So outside medium, when I take it to be 1, when I apply Snell's law at this point, what do I get? 1 into sin I will be equal to mu into, yes, mu into sin R, which implies mu will be equal to sin I divided by sin R. Is that right? So if I take this as 3, then I'll say using 1 and 2 in 3, what do we get? We get u is equal to sine of a plus delta m by 2 divided by sine of a by 2. So u will be equal to sine of a plus delta m by 2 divided by sine a by 2. Is it clear? Okay. Now, when you plot a graph which shows the variation between delta and I, then the graph you draw will look something like this. First, it will decrease as the angle of incidence keeps increasing. The angle of deviation will first decrease and then again start increasing. Okay, and there is one particular point at which you have the least angle of deviation, and that is a place where I will be equal to E. This is here. Done. Do this activity in school. Have this experiment. Okay. Right. Shall I proceed? So this is all about the condition for minimum deviation. Right. Next is the concept of dispersion of white light. So you know that prism exhibits the property of So what do you mean by dispersion? Dispersion is splitting of into its 7 constituent colors. So splitting of white light into its 7 constituent colors is what is called as dispersion of white light. Is that clear? So if I take this to be ABC, right? So it will get split in such a way that it has 7 constituent colors. Is that right? So if you observe, this will be violet. Then what do you get? Violet, indigo, blue, green, yellow, orange, red. You know this, right? So this will be violet and this will be red. Okay. So among all these, which one has the greatest wavelength? Red. So we say visible light has a wavelength between 400 nanometer to 700 nanometer, right? Or 450 to 750. Some books refer it like this. So keeping all these things in mind, if you see among both, which one is undergoing more deviation? Violet. So violet is undergoing more deviation compared to red. Okay. So that is a point that you need to make a note of. Right. This is all about the prism, right? These are all the concepts that are related to prism. Any doubt till here? Here?
Yes, sir.
Okay. So just touch the topic we discussed in previous class. So previous class we discussed about lens maker's formula, right? So I gave you two important points also out of that. What are they? When you immerse a lens into a medium of greater, of more refractive index compared to the lens itself, the nature of the lens will change. Means the converging will start behaving like diverging and the vice versa will happen. Right? That point is clear. What else is the point I gave you? Only one point, no? Okay. So I just wanted to add a few more points to that. If you have some space, go and write it there. So you have a lens, okay? And if the lens is cut into two equal parts perpendicular to the axis, if you cut it into two equal parts so that one will look in this way and the other will look in this way. Is that right? So when this kind of a scenario occurs, what will happen to the new focal length? If I call this focal length as f dash and this focal length also as f dash, then what is the relation between f dash in terms of f? If I say the original focal length of the lens was f, what do you think will happen to f dash? Will it be the same? Will it increase? Will it decrease? Nothing will happen. So it should be the same. So what I would suggest is apply lens maker's formula and try to find it. I'll do for the LHS part C. 1 by f is equal to. So this is what you are supposed to write, no? This derivation. I hope everybody knows the formula. What is it? Mu 2 by mu1 minus 1 into 1 by r1 minus 1 by r2. Is that right? Okay. So what is mu2 by mu1? Okay, I'm not disturbing this. mu2 divided by mu1 minus 1 into 1 by r1 minus 1 by r2 is how much? I told you the previous class it is 2 by r. Is that right? So in a similar case, if I try to write the expression for 1 by f dash, what will I get? Mu2 by mu1 minus 1 into 1 by r minus 1 by is the planar surface, no? 1 by r minus 1 by infinity, because for a planar surface, what is the radius of curvature? It is not defined. So what will you get 1 by f dash as? Mu2 by mu1 minus 1 into 1 divided by r. So what is the relation between f dash and f? F dash will be equal to f divided by 2. Means the focal length will become exactly the half of the original focal length. Why is it happening? Because of the planar surface. Make a note. One of the surfaces is spherical, it's straighter. When you cut it perpendicularly, this is a planar surface, this is the curved surface. So the curved surface is borrowed from here, planar surface is this. Is it clear? Clear or not? Yeah. So one last point associated with this is see, if I have the same lens and the lens is cut into two equal parts along the axis, then what will happen? One surface will be like this and the other will be in this way, right? Say the focal length of the old lens is f. What will be the focal length here? F dash and f dash. There will be, what will be the answer? It will be the same because both the surfaces, you are not disturbing the radius of curvature in the nature. Why would it change? Whereas the previous case, what did you do? You made one spherical surface into a planar surface. That is why the focal length changed. Then nothing will happen. But only thing is intensity of light will decrease. That's it. Is that point clear? Okay. So these are all the concepts for today. The last topic that is pending is optical instruments. Optical instruments, you have simple microscope, compound, and telescope. So these are the three concepts. Maximum will finish it by tomorrow. Okay. So today, you write the test on the topics discussed the previous class. That is the derivation for lens makers volume.
Sir?
Tell me.
Sir, in last class, I asked the doubt, right? Wheatstone bridge effective resistance, which is in terms of Wheatstone bridge. Sir. I sent you a pic to your WhatsApp, sir. Can you check?
You first finish the test. I'll check it. I didn't get it. When did you send? Now. The middle three will become ineffective because it's a balanced Wheatstone bridge. Okay. So observe. I'm writing it here. 2, 4, 3, 6, 12. So R1 by R2 is the same as R3 by R4. So this 3 will be ineffective. Okay. 2 and 4 are in series. This will become 6. 6 and 12 are in series. This will become 18. 6 and 18 in parallel. So 6 into 18 divided by 24. It goes 4 times. Answer will be 9 by 2. Is there an option? 4.5 is answer.
Sir, so the middle resistance doesn't play a role.
No, if it is a balanced Wheatstone bridge, you need to remove the middle resistance because no current will flow through it. Okay.
Okay, sir.
So start writing. Yeah. So write the date, name, and everything. And the heading is derivation of lens makers formula. You exactly have 30 minutes time. Finish it off. Time minutes. Nitin, Joseph. Those are online.
Sir,
Yes, sir.
Submit your papers. Yeah.
submitted, sir.
Submitted.
Submitted, sir.
And we can wind up this session.
Thank you, sir.